Hopefully this will just be a short introduction to get you guys mentally prepared for having to multiply with the integers. First, let's show you the different symbols that are used for multiplication. We've got the letter X. You are used to using the letter X for such expressions like 3 times 4. This is what you are used to. But it looks like a letter. And X is the variable used in algebra. So we are going to try and not use the X from here on out. I mean, sometimes it will appear, but for the most part, I need you guys to get used to different representations for multiplication. The second representation is just the famous dot that looks like this. Okay? So this, though, you can get confused with a decimal, because if you're not careful, notice how it's in the middle. So here is what the decimal looks like. Go ahead and put this in your notes. Versus multiplication. So that's why we really don't like using the dot, is because when we're dealing with decimals, very many people will make it look like a decimal. Last but not least, the parentheses. You guys are used to a set of parentheses. However, instead of grouping with parentheses, you can also use the symbol for multiplication. That looks like this. So notice how there is no space, okay, between the set of numbers and their parentheses. That means to multiply, okay? You can also do it like this, where the leading number is open with no parentheses, okay? And more importantly, there's no space in between. Okay, so the 3 is right up against the set of parentheses that contains the 4. So this 2 means multiplication. This is most common in high school. So we need to get used to that way, okay? Let's keep moving on. Do me a favor, go ahead and pause your screen and copy down on your notes what you see, and then push play when you're ready to take notes. Okay, at the first number line, this is how you show repeat addition. You're adding 2 7 times. So what we're going to do is we're going to represent that as an actual multiplication problem. So we're going to, it's basically saying 7 groups of 2. So I'm going to say 7 times 2, which gives us 14. Let's go down to the negative part. Let's go and represent 3, but this is a negative 3 since it's going left, okay? So negative 3, whatever we do to negative 3, it's going to equal negative 12. And then how many groups did we form? 4. So 4 times negative 3 equals negative 12. So 4 groups of negative 3 equals negative 12. Well, on the next one, try to figure out what the question marks are. What is the distance of each arrow? Because you can see that it's 3 representation. So it's going to be 3 times that negative number, okay? And it's going to end at negative 15. So what times 3 can possibly give us a solution near a number that's 15? If you said negative 5, that produces a negative 15, you are correct. So the distance of each one of these is 5 units. And we know it's negative because it's going to the left. Okay, the next section of your notes, you're going to perform some multiplication numbers without a number line. So you're actually going to show repeat addition to make sense of why your answers are the way they are. So take number 1. We've got 3 times negative 5, so that's 3 groups of negative 5. We know that negative 5 plus negative 5 plus negative 5 is essentially negative 15. So number 2, we've got 4 groups of negative 6. So negative 6 plus negative 6, I'm going to write this out 4 times. So we know that we keep getting further negative, so my answer is going to be negative. Well, 6 and 6 is 12, and then another 12 will be 24. So negative 24 is your answer. Number 3, yes, I know you know what to do now. So you do 2 groups of negative 9. Notice that we're adding. This produces negative 18. Now look at number 4. Do you see any difference? Yes, the negative is first and the positive number is in the parentheses. But that's okay. You can actually switch it, because just like addition, okay, no matter which way you multiply, it's going to get you the same result. So just go ahead and represent this problem as 4 groups of negative 3. So that's negative 3 plus negative 3 plus negative 3 plus negative 3, which is negative 12. Okay, go ahead and copy down 5 through 10. We are actually going to do, whenever you see a negative number first, we're just going to switch it around so that the positive number, okay, is the leading number. So this we have 5 groups of negative 1. I'm going to add negative 1 5 times. Which ends up being negative 5. Number 6 switches to 3 groups of negative 3. So I know that 3 plus 3 plus 3 is 9, but it's going to be negative because all the numbers that we're adding are negative. Go ahead and pause your screen. Finish all the way through 10, please. Push play when you're ready to see the answers. Okay, make sure you look at the answers, please. Check them. See if you got it correct. At the bottom, I ask you a little question. What did you notice about all the answers? All the answers are negative. So if you said that they were negative, good job for you in recognizing the pattern. Let's try and let's go on to the next slide. Okay, for this slide, please go ahead and push pause and copy down what you see. Push play to resume for further instruction. If you notice the pattern from the previous slide, all you recognize that you're still going to multiply the numbers together, okay, but only your answer is going to be negative because one of these digits is negative. So let's try it mentally, looking at the first one. I know that my answer is going to be negative because one of the digits is negative. And I know that 5 times 7 is 35. Same thing with B. I know my answer is going to be negative because I have 6 groups of negative 8. Remember, we can rewrite it like this. So 6 groups of negative 8, that means my answer is going to be further negative. 8 times 6, negative 48. Now, don't get overwhelmed with the fraction, because anything times 1 is itself. So again, you just have to make sure it's negative. Tricky, part D, 5 times 5, both of these are positive, so your answer is going to be positive. 3/4 times 2, well, just take the 3, multiply it times 2, and then take the 4 and multiply it times 2. Just remember that your answer is going to be negative because one of the digits out of the 2 digits that are there are negative. So we get 6/8. 3 groups of negative 9, our answer is going to be further negative. 3 times 9 is actually 27. So if we were to draw this on a number line, it'd go all the way down to negative 27. Okay, really quick, let's look at the one expression that I just added. This time it's 3 digits. So just like addition, okay, you can apply the commutative property and you can multiply them in any order that you want to. So I'm going to actually multiply the 2 times the 3 first, and then multiply it to the negative 8. So notice how I'm writing my parentheses. Okay, inside this parentheses, I'm going to go ahead and take 2 times 3, and notice that there's no space between the parentheses of the negative 8, okay? You can actually write this like this too. And this means I'm going to follow order of operations and multiply in order from left to right. But of course, that's after I switch them around. So 2 times 3 is 6. So I'm going to simplify. 6 times negative 8. Because one of the digits is negative, I know my answer is going to be negative. So I have 6 groups of negative 8. Just a question for thought. What if so far we've been multiplying one negative and one positive together, but in a circumstance, what if you had a negative times a negative? Okay, how would you model that one on a number line? How would you write that one out as a shortcut instead of repeat addition? Do you even know what the answer would be?